Hi, in this video, we're going to talk a little bit about serial communications. Okay, so serial communication, first of all, it's part of the WAN, the wide area network, which is owned by a service provider. Sometimes referred to as a serial connection or leased line or serial link connection. Uh, and the subscriber is paying for a continuous connection between the two sites. So although sometimes it shows as kind of a direct connection between these two sites here, a lot of times, well, all the times, there's all kinds of equipment in here, different kinds of multiplexers and demultiplexers, repeaters, line conditioners, and all kinds of things in there. And what actually this may be can be all sorts of things. But as far as the subscriber is concerned, it looks like a single contiguous link between the two sites. And the subscriber is paying for this always on connection between the two sites. So it's a reserved circuit. Sometimes we think of it as a private leased line circuit between the two remote sites. Okay, so a little bit on serial communications, which is which is used by our serial links, which is a method of data transmission in which the bits are transmitted sequentially, so one after the other, as opposed to parallel communications, which transmits multiple bits at a time. In a lot of older PCs, we used to have RS-232 serial ports, and we also had parallel ports. A lot of times we used serial ports for connecting to things like, wow, in the old days for the mouse, some printers, but then we moved to parallel ports to send data to the printer, because parallel communications, being able to transmit multiple bits at a time, we can actually, in a short distance, be able to send data faster over a parallel link than we can serial. But that's parallel communications because of synchronization issues and some other things that, and also and expense as well. We use serial links over longer for our leased line serial link connections. But anyway, serial ports and parallel ports on the PCs have pretty much been replaced now by USB interfaces. All right, so we're going to be talking in this series of videos about point-to-point links, which again, it's a permanent dedicated connection. Provides a single pre-established WAN communications path between the two remote sites. And really what the single connection goes through is from one site to a service provider's network, and then from the service provider's network to the other site. So what this actually looks like in here can be all sorts of things, as I mentioned before. All right, this all comes about from many years ago when the telephone companies came up with something called time division multiplexing. And I talked about this in a previous video, in which communications is actually multiplexed over a single link. So they could actually send 24 separate channels of data of 64,000 bits per second per channel over this T1 circuit, or as we'll actually call it a DS1 circuit. This is known as a digital services hierarchy. The term T1 was actually originated by the phone company for a specific type of equipment. But DS1, or these DS0 channels, this would be a DS1 circuit, has 1.544 megabits per second. So the way we get that is it's 8 bits per channel. At 8,000 channels per second gives us 64,000 bits per second per channel. So each one of these channels here is referred to as a DS0 channel. And the 64,000 bits per second accommodated a single phone call. So over a single cable serial connection, a T1 circuit, they could send over this single physical circuit, they could actually send 24 channels, 24 phone calls. You could actually use this for data, and you can actually, what we call fragmented T1. So you might purchase a certain number of channels for your data. It's called a fragmented T1, or you might purchase the whole thing, the entire circuit, for a T1 circuit. Okay, but that's really the kind of the underlying digital hierarchy that we see even today. So that's why you see a lot of things that, older circuits, 64K, 128K, 256K, 1.544 megabits, etc. So this is shows kind of the more up-to-date, more current digital hierarchies, starting with the North America hierarchy of digital services DS0 through DS4. Also talked about this in the previous video, sonnets, optical carrier standards. And we've got the international standards. So North America uses the T carrier specification, European E carrier, and US uses the OC optical carrier for discussing transmission rates. All right, but anyway, I just wanted to share that with you. So back to our point-to-point links. So we're going to talk a little bit in this video about HDLC, which is high-level data link control. This is the default point-to-point. This is default encapsulation on point-to-point connections on Cisco devices. So on a serial interface that we'll see here in a moment, the default encapsulation is HDLC. PPP, as we'll be talking about in a later video, and actually it looks like I've got circuit misspelled there, but that's okay. We're going to be talking about PPP later, but PPP actually uses a similar framing, layer 2 framing format as HDLC, but has other features built in, like security mechanisms such as PAP and CHAP and some other things, as we'll see more later. There's the terms synchronous and asynchronous that are used. So up here, the least line, you see synchronous circuit, circuit switch, you see an asynchronous circuit. So the terms synchronous and asynchronous. Synchronous means with time, which means a common timing signal is used between the two devices. So either the provider actually provides this timing signal, or one of the two ends. It's why in our labs we have to do things on one end, typically whatever end has the DCE cable in a lab environment, we actually have to provide some sort of clock rate. Asynchronous means without respect to time. There's no clock or timing sources needed, and this is what you see in the PSTN, public switch telephone network. There's also another type of protocol used in circuit switching called SLIP, Serial Line Interface Protocol, but that's been displaced by PPP. In the world of packet switching, so first of all, packet switching does use serial to connect to the packet switched network. When we're talking about some legacy layer 2 packet switch protocols, X25, which used to be one of the mainstays of early service provider packet switching, which was later replaced by frame relay and ATM, but all three of these are pretty much legacy. I haven't seen X25 around in a long time. There's still a little frame relay out there, but I know AT&T hasn't supported frame relay for many years. So a lot of this has been replaced by other technologies such as MPLS that we talked about in a previous video. All right, so let's get into HDLC, which is the default encapsulation on most Cisco serial interfaces. It was developed by the Organization for Standardization, ISO, which is not an acronym for Organization for Standardization. ISO comes from the Greek word isis, which means equal. Defines the layer 2 framing structure. So you can see a little difference between the standard HDLC format and the Cisco HDLC format. It is the default serial encapsulation on Cisco routers, and Cisco's difference is it includes a protocol field, which indicates what type of data is being carried over the HDLC frame. As far as encapsulation, it's on most Cisco devices, it's the default encapsulation on serial interfaces, but if you want to manually configure, maybe you had PPP as your encapsulation, which we'll be talking about more later, want to change it to HDLC, you might be able to, on most iOSs, just type no encapsulation. That will always revert back to the default, but I always like to be sure. So whenever you want to make sure the encapsulation is HDLC, you just say encapsulation HDLC in the interface serial submode. All right. As far as verifying it, if we do show interface serial 000, we can see there the last line. The rest of the output has been omitted, but we can see encapsulation HDLC. There's also another command you should become familiar with, and that's the show controllers command. The show controllers command will indicate any of the physical specifications on the interface. It will show a lot of the things that you configure the CSU, DSU for, but as we can see there that it shows that the type of cable that is attached. Here we have a DCE V.35 cable connected connected on the serial 000 port. You could also, depending upon the type of interface, it might be a EIA TIA 449 or something else. But if you ever see unknown there, instead of DCE V.35 in our example, then chances are you have some kind of interface problem, maybe a loose cable or the cable isn't connected at all. Okay. All right, so we'll talk a lot more about serial communications in the upcoming videos.